So the agenda for today, we're doing, I'll do a quick intro to the course and myself and our organization, and then we'll jump right into a quick intro on analytics and data science. For today's course, I really want to focus particularly on application for work and life, and some of the interesting examples that I can share that I hear about or that I work on. And then we'll go into looking at the different types of data, really high level, so I won't get into any sort of technical or statistical details. And then beyond that, looking at the types of analytics, and then going into more application in analytics in different projects. So just a quick background about me. My name is Eric. I have 3 degrees. I have a business undergrad, economics undergrad, where I focus on econometrics, which is just a fancy word for economics for statistics for economics. As well, I have my Master's of Science in Analytics. I've done a lot of projects in analytics consulting, particularly, so I started this analytics consultancy about 4 years ago, and we've worked on a lot of kind of interesting cool projects. And at the end of the session, if anyone wants to stick around, I can chat more about kind of the type of works I do, or even starting a analytics consultancy, what that's like. It's a very interesting venture for sure. And then most importantly, I think for you guys, I'm an educator in statistics, analytics, and economics. I've been teaching for about 15 years now. And this particular analytics course, with some modification for this year, I've actually been teaching for about 4 years. This is probably the 20th time I've taught this course. So you're in good hands. Just a little bit about me. So just fun stuff if you ever want to chat with me outside of work stuff. On the top left, so I'm a trained barista. I learned how to make latte art in Italy, so that was fun. In the top middle there, I'm an avid volunteer. So pre-COVID, at least, I volunteer at least once a week at various children and women shelters. I'm a bit of an artist. So on the top right there, it's a painting that I did. Bottom left there, it's a dinosaur vault at the Royal Ontario Museum that I was super excited to look at. Bottom, the picture, that's me on a motorcycle racetrack. And then bottom right, that's me at my graduation, which is now quite a few years ago. So Advanced Analytics and Research Lab, we're a full service analytics solutions and service company. So for us, analytics and data science, it's not just a department, it's not just a profession, it's really a mindset, and it's a problem-solving methodology. So for us, it's one of our core mission is to make sure analytics is available for everybody in various capacities, and this education is kind of really important for that mission. We have 4 lines of services. So we do analytics solutions, consulting, analytics services, and education. But essentially, the easiest way to remember what we do, we're the fastest and easiest way for an organization to gain analytical capabilities. And what we always say, for the price of one analyst, you can get an entire specialized team to do analytics and data science. Our education mission, really to find a practical way for everybody to start using analytics in their day-to-day. So what does that mean? Provide research and content through our different media channels, run live or in-person webinars. I love teaching, so we actually run a lot of physical workshops, but definitely not this year. Provide online education content. So we have an insight center on our website, as well as online courses you can take. We try to keep it free or very low cost. And talking to other people at conferences, sharing our learnings for various projects, and then showcase interesting projects. So this fall, we're running 4 classes: Applied Analytics, Excel, and R in Science of Data Visualization. data visualization using BI tool like Qlik, and then intro to R with statistics. Some of the upcoming ones, some high ROI analytics for management execs, HR and people analytics, social sector analytics. And I mentioned the profits are donated to charities. So what is data science? So jumping right into it, actually, let me flip back to see if there's any questions. Cool. Okay, so what is data science? Data science is a cross-disciplinary field. So usually when we talk about data science, we try to break it down into kind of three circles in this Venn diagram here. So computer science and databases, math and statistics, and then subject matter expertise. So what is the subject matter expertise? Usually that's whatever kind of problem or industry or function that you're with. So for example, subject matter could be if you work in, I think I hear someone say they were from healthcare, then what is healthcare data science and healthcare analytics? Or if we're talking about specific functions, so there's things like accounting, HR analytics, financial analytics, management analytics. So those are all very specific things. But most importantly, data science, right? It's the science of data. So it could include everything from collecting data to analyzing the data to using the data for specific purposes. So how does data gets turned into value or results? So, there's a classic kind of example, more like explanation. So, we have data, which is the raw and unprocessed information. And then we turn that into information, which is kind of more contextual, depending on what data is for. So there's certain patterns or aggregated statistics. So aggregated statistics, I mean, things like sum and averages and count and those kind of statistical calculations. And then from information, we have insights. So really insights is like information plus some sort of logic or kind of more context. And then beyond that, planning, action, and outcome. So just to kind of drive that home a little bit more, here's a real life example, right? Let's say you care a lot about fitness and how much exercise you get. And you have a tracking such as a smartwatch, so your Apple Watch or whatever devices you use or Fitbit, and you can track the number of steps or activities per day. So the data from the previous slide for this, you track how many steps you take per day. And then some useful information. Okay, maybe you're looking at your historical data for the past week and you notice you take less steps during the weekends. So some insights you can drive from that. Okay, maybe it's because you stay home on the weekends. So maybe you should probably have more, specific activities on the weekend so you can make sure you're getting the same amount of steps or activities. So then from there, you plan. So you figure out what you want to do for a weekend. Maybe you want to take a tennis lesson or go to the gym or just, take some walks with the family or go on hikes, things like that. So actually executing and doing what you say you're going to plan to do. And then outcome, you'll get more steps on the weekend. And then I guess the ultimate outcome, which is, be more fit or get more exercise. So analytics in your own life, if you think about analytics, it's a problem solving or decision making mindset / method. So if you think about how many decisions you make per day, right, work versus non-work, it's going to be in the hundreds, if not thousands. So a decision could be conscious or subconscious, rather. So, whether when the alarm rings, if you want to wake up or not, or hit the snooze button, should you brush your teeth or not. So those are kind of subconscious. You don't really think about it. And then there's more kind of conscious decision making. Which route are you going to take to work that has less traffic? Sometimes that might be also subconscious. The sayings. A big part of life, it's like on autopilot. You don't really think about what exactly you'll be doing most of the time. You just know you have some sort of routine and you go do it. But what I'm trying to say here is that applying some data and analytics can perhaps help you with your continuous improvement by tracking the metrics that you care about and using that data to make things more optimized, whatever that means for you. So just some examples, analytics for life. For me, money. So, you have your bank accounts, and I actually have I think it's called Mint, which tracks your spending and profits across time and things like that. Fitness, so the smartwatch fitness tracking I was talking about. Diets, how much money do you spend on food and how much nutrition are you getting? How you spend your time. Toothbrushes. So I have a toothbrush that actually tracks which area of my teeth is getting cleaned and how long I'm cleaning my teeth, and then it's linked to my phone, and there's an app that tells me how I'm doing across I think 4 different metrics. And then phone usage. So a big thing I talk to people about, it's a screen usage time. So for most phones, you can actually track how often is your screen on. So for me, it's about 2.5 hours a day I'm using my phone. But I was teaching a high school class a couple of weeks ago, and a lot of the students say they're doing more than 5 hours a day on their phone, which is good and bad. So if you want to participate, I'll take a few seconds, maybe type into the chat, what are some of your examples you use in terms of analytics in your personal life? Okay, Michelle says diet analytics, what I eat and when. Emerald, tracking my spending. Any other examples? Tracking exercise from Omar. Tracking sleep. Yeah, tracking sleep is a good one for sure. Employee productivity, sleep, driving. Yeah, driving is a fun one. I definitely spend a lot of time pre-COVID on the subway. Spending Fitbit. Great. Okay, so going back to the slides. So here's actually a quick example of my my life. It's a kind of a funny thing when I show people. So I track my day down to the hour. So this is, I think, 2019 data. I track all of my free time. So work, obviously, we have a very sophisticated tracking tool because I'm a consultant. So we track things down to the minute. But for my personal life, and I took out sleep out of my pie chart here. But I spent 37% of my time with my girlfriend, 5% of time with my friends and family, and so on. And at the end of the year, I'll actually compile all my data and say, okay, 5% of time with my friends, that seems a little low. I'm going to try to boost that up for next year to 7%. And it's obviously never perfect, and I don't track it super accurately, but it's a pretty good proxy to know, what I want to do and how I want to spend time with my life. So just a funny example. Some other interesting use of analytics, obviously COVID, very hot topic. We actually did a COVID bed simulation and prediction for some hospitals in Canada. So pretty familiar with the different nuances of all those data. The Toronto Raptors, that's also a bit of a hot topic, but maybe I'm a week too late on this topic since they just got knocked off the playoffs. But how did they win the NBA using analytics and AI? Intelligent traffic analytics. So how do we I'm always very, very curious about the process of deciding how long each red light is going to be. And a lot of times, I'm sure all of you have this, you're sitting in traffic and you think, oh, this red light is way too long. There's no cars on the other side. And there's a lot of research on that. Even more fun use of analytics. So last week I saw this news article, UFO sighting is increased 51% compared to the same time last year in the US. This was reported from, I think it was two different news article. So, is there actual correlation between the pandemic and UFOs, or is there some other underlying reasons indirectly increasing those sightings? I won't comment on my thoughts. What leads to romantic attractions? So that's actually a very, very fun topic as well. So there's a lot of studies on how people get attracted to each other, and different apps like what they call Tinder, and there's other big ones that I can't think of off the top of my head, and then they all use that data very, very interestingly. This is one of my favorite books on the bottom right, How to Lie with Statistics. It's hilarious, and it's from, I think, the 1950s, and everything in there still stands. But a lot of what it talks about is like how to be skeptical with statistics that people show you. And then bottom left here, another super interesting case. So I think about 100 years ago, there was a ship carrying $200 million worth of gold that was traveling from California to New York by boat, and it actually sunk during a storm. And I think about 10 years ago, there was a group of scientists got some funding from investors and then actually found the boat, and they did so using optimization models and simulations from a variety of things. Just do a quick check to see if there's questions. Cool. All right, so problem solving and decision making. I almost always say that this fourth step in the middle here. If you learn anything from today's lesson, maybe it's this one. This is Eric's / not really Eric's trick. 4 steps to solving every single problem in life. So anytime I'm ever stuck on anything, this is kind of the framework I go back to. So first off, you have to realize there's a problem. But once you identify the problem, then you go through these 4 steps. So number 1, what's the objective? So what is the criteria in which the problem can be solved? So it could be a set of criteria. Let's say you're buying a new TV. So that's quote unquote a problem, right? So what is the objective? Okay, I want a certain size. I want a certain resolution. I want it to be on, whichever room you want to put it in. And then number 2, you go into options. So you figure out first creatively as much option as possible. So, maybe you'll pick out, go to the store and, look at 20 TVs. So those are your options. And then number 3, you analyze each options and then match that against your criteria or objective. And then number 4, you make a decision and you pick. So that pretty much every single problem falls into this 4 steps. I'm sure there are exceptions. I have yet to really find one. And then beyond that, once you make a decision, of course, there's planning, and then there's action. And then the last part, a lot of people don't think about, but contingency, like what could go wrong. You should always be prepared for things that could go wrong. So going a little bit more into practical work applications. So for most businesses and organizations, it follows sort of these, how many is that? 10 steps. So organizations start with no data, and then they start with collection. So going from left to right in terms of sophistication, but also left to right in terms of return on investment and potential value from these steps. So no data, data collection, some sort of reporting, ad hoc analysis. So ad hoc analysis meaning, if you give a boss a report, if the numbers are going down, then he'll say, oh, how come it's going down? Can you go look into that? So that's kind of ad hoc analysis, kind of on-demand questions that you want to answer. And then there's business intelligence, which is more structured decision-making and reporting. And when we talk about BI, usually the tools we're looking at is things like Tableau, Qlik, Power BI. There's tons of other ones that exist, but those are kind of the three big ones. If you use IBM, there's Cognos. And then we go into what I call advanced analytics. I call it because my teachers and mentors calls it that. So descriptive, predictive, and prescriptive analytics. So we'll spend a big part of time today talking about that. And then afterwards, there's machine learning and artificial intelligence, which is obviously a super hot topic in the past few years. So why is machine learning AI like a super hot topic? So there's this fourth industrial revolution thing that I'm sure many of you have heard of. So what is the fourth industrial revolution? So going from the first, right? The first industrial revolution, we're looking at the mechanical kind of boom, and there's more machines automating things that requires human physical labor powers. And the second industrial revolution goes into more things like assembly line, electricity, and your kind of modern factories are born here. The third industrial revolution comes with internet and computers. So there's more automation, information flow. And then the fourth industrial revolution goes into Internet of Things, cloud technology, AI, and machine learning. So going from the first to the fourth, imagine, if you have a farm, 100 acres of farm, maybe 100 years ago, 200 years ago, you need maybe 200 people to manage that through the year. Now with equipment and tools and machines and things like that, maybe you go from 200 to 100 people. And then with more, big tractors and more automation and things like that, you go from 200 to 100 and now to maybe 50. And then the fourth industrial revolution, and maybe the final one, maybe one person could farm 100 acres. And that's certainly, a case for a few of the use cases out there. I've seen interesting videos where, a family of 4 people has a fully automated farm that's like in prototype phase, and, you can farm the entire thing with just computers. Super quickly. So AI machine learning, just like some classification frameworks for people who's not as familiar. So AI, broadly speaking, is a subject under computer science. And then computer is technically a subject under like mathematics. So the umbrella goes mathematics, computer science, AI. And then under AI, there's things like logic, machine learning, knowledge representation, robotics, and things like that. And then under machine learning, there's kind of 4 main types: supervised, unsupervised, and reinforced learning. I won't get into this at all, but we might do a separate class on machine learning AI. Problem solving with analytics. So always start with the question at least from a organizational and business perspective, right? You start with the question, you figure out the strategy, stakeholders, and what data you have. You analyze the data, you make recommendations, you execute tests, and you assess the outcome, and then you kind of do that whole thing round and round. And for those of you who's looking to get into a career in analytics and data science. This is sort of the spectrum I tell people. So on the left, you have more business or non-technical, and on the right is more technical, which is more focused on mathematics, modeling, computer science. So, you go from general analysts to business analysts or data analysts. Then you go into more BI type tools, then data analytics, data science, then the data engineer and machine learning experts. Obviously, there's some exceptions, and depending on, I think, which region you're from. So the way we talk about data science is actually a little bit different between US and Canada as well. So in the US, data science and analytics, it's a little bit more defined, whereas in Canada, it's those two roles sometimes gets used interchangeably. So super crash course on data analytics. So this is kind of from what I gathered, but there's probably some real history you can go read. So OR, which is kind of the granddaddy of data analytics, operations research, primarily was used for nowadays for manufacturing, but it came out of World War I, and it's using advanced analytics, mathematics to make better decisions. Management science, so World War II, people started to realize after World War II, all this interesting statistics and analytics that's used in the war, like probability of where the enemies might be and mathematics of logistics to ship supply to the troops, things like that. You can use those in business settings as well. And then the term data science was first used in 1996 in Japan. So that was off of an internet article. I don't know how true and factual that is, but the point is more, this is actually a relatively new term, data science. And really only in the past, I think 10 years was data science really used more as a term that's being disseminated into the business world. Different types of data. So I won't speak too much into the detail of this, just a high level framework. For data scientists, usually you're looking at structured versus unstructured data. So structure would be data in a database in tabular format, whereas unstructured would be everything else. So videos, photos, text documents, and things like that, tweets, social media posts. And then we have big versus small data. So there's like some exact definition for big data. But what I usually like to say is big versus small data. For big data, it's big if you have to be clever about how to analyze the data, meaning small data is usually data you can just analyze on your personal laptop. Generally, for a modern computer, you have 8 gigabytes of memories to maybe 16 gigabytes nowadays. So kind of 5 to 8, maybe 10 gigs of data you can analyze. But for example, in Excel, the biggest files you can probably open maybe 2 gigabytes. Anything bigger than 500 megabytes, your computer is probably going to start choking a little bit. Okay, so going to more traditional or statistical definitions of data, we have cross-sectional data, time series data, and panel data. So cross-section is basically a snapshot in time. So let's say for a grocery store, at any point in time, the snapshot of its inventory as of, let's say, today is September 15th, how many apples are there, how many oranges are there, and how many bananas are there. Whereas time series is data across time. So how many apples are there today versus yesterday versus the day before? And time gets really, really tricky, especially when you're trying to analyze data. And it requires a whole set of extra consideration. So cross-sectional is the easiest, time series gets a little wild, and a panel is the hardest, which is essentially a combination of cross-sectional and time series data. Cool, so that's the end of first section. Go back and stop sharing my screen. Oh, I stopped. Okay, great. Okay, seems like there's no questions, so I'll just jump right into the types of analytics. Go. Cool. Okay, so types of analytics. We talked about earlier, so 3 general types of analytics: descriptive, predictive, and prescriptive. So descriptive, pretty much it's in a name, pretty self-explanatory. You're describing past event using data. So some popular methods, going from easy to hard. So averages, right? Excuse me. So averages, and there's many different kinds of averages. So usually we talk about the 3 main kinds of averages in statistics, which is mean, median, and mode. But I think theoretically there's like more than 10 different types of averages. There's like geometric averages and all that fun stuff. Standard deviation, so the spread of your data. You can use cluster analysis to segment data and things like that. In terms of visualization, you have your 3 big ones: bar chart, pie chart, and line graphs. Just a quick funny note there. Bar chart can probably visualize like 95% of all your data. Pie charts, if you're a serious data scientist, is actually a very hilarious debate about is pie chart useful or not. So there's a book which is like the Bible of data visualization called Visualization of Quantitative Data or something like that. And a lot of data scientists basically make fun of pie charts because a lot of people use it improperly. Other more advanced techniques. So next Tuesday, we have our data visualization, art and science of data visualization. So we'll talk more about it later. Analogies. So descriptive analytics or descriptive data, you can look at financial statements. And here's just some of example of visualization. So on the left, you have the line chart. On the bottom, you have a scatter plot with different segments in the circles. And then on the right there, you have a dashboard. So why is descriptive analytics important? First off, it's really important to understand, I think, relationship between variables as well as trends across time. And really, right, no more guessing. If, organizations, I hear this sometimes from our clients, sometimes the manager gets frustrated because, he'll say, okay, how did this happen? And people be like, I don't know. So going from I don't know to I know what happened, and how did it happen? Why did it happen? Or even did it happen? Can be super important. I almost don't want to say it's important. I want to say it's necessary. Understanding what are main variables affecting your desired outcomes. So descriptive analytics can be pretty advanced because people want to understand how to achieve your desirable outcomes. And descriptive analytics allows you to pull on different levers to help you achieve your outcome. So as an example, let's say you want to know how to increase and manage your leads, sales leads. So let's say you are a hairdresser, right? How do you increase customers into your shop? Well, you can try to analyze your data from your different marketing sources. So how much money are you spending on your advertising and marketing? How many people are looking at it? And then going down to how many people are looking at the ads to booking an appointment, and how many people are booking an appointment and showing up. So very quickly there's like 4 different steps. And between all those 4 different steps, you can calculate a ratio of its success. And once you know what is good and bad for each one of those ratios, then you can try to pull on it, right? So, if I know there's not enough budget being spent to get the impressions, okay, then I should spend more money on the budget, and I should make my advertisement better, right? But if those two are doing well, maybe it's because people are going to the website but not actually booking. So then you should make the website better, right? So really understand and breaking down different parts of your primary activity is super important. Business case example, so cluster analysis, really popular one, customer segmentation based on attributes. You can group them to allow for more granular marketing efforts. I think especially for larger firms, this is pretty key. If you have, thousands of potential customers, how do you give them a more personalized ads as well as more personalized offerings? And you can think about, for example, clustering for airplane, right? So you have your first class, your business class, economy, and the way you sell to all of them and what those customers care about are all very different. So you can use cluster analysis. Regressions, so housing prices, for example, so you can understand the relationship between housing prices and number of bedrooms, square footage, number of fireplaces, how much sun it gets, and all that fun stuff. Quick check on the chat, no questions. Great. Okay, predictive. Using data to predict and forecast / making an educated guess about the future. So pretty self-explanatory. The easiest example for this is the weather forecast, right? If you think about how useful tomorrow's forecast is, and even 10 days forecast, how useful that is, you wonder how people live before weather forecast is even a thing. And especially in Canada, we have the Weather Network, and that's the story of the Weather Network is super interesting. It's actually the founder of that company is actually from my school, and I met him once, and he talks about how he was able to gather the data and kind of make the whole thing happen. I'm not sure, but I believe also there might be some Weather Network stuff in the US, like the Weather Network's a company for our US friends on the call. Popular methods. Using regression from the previous example with the housing, you can actually make statistical forecasts. You can also do forecasts using cluster analysis or things like neural networks. So neural network is a machine learning / artificial intelligence model, but it actually works very similar. All of these different algorithms works pretty similarly. So analogy, right? So if you have a financial statement, okay, then you have to do a forecast on your financial statement, predict what your next year revenue is going to be and things like that. So some examples on the top, you can kind of see, there's your historical data in the dark blue lines, and then there is your predicted data in the dotted red lines with the shaded blue. So that's confidence interval. Quick tip. Prediction, when you're giving a prediction, anytime, it's always better to give a range. So first off, giving a range, you're a lot more likely to be right. If the probability of you giving a number and your predicted number being exactly right, so let's say you say, next year our revenue is going to be $10,600,000. The probability of you being right is almost zero. So it's almost better always to give a range. And economists gets a lot of bad rep for not being able to predict things right. But usually when economists predict things, what's the GDP or unemployment rate for next year? Usually they give a range, but then when it's reported, I think in the news, they usually just use a single number, and they're pretty much never right because of that. Business case example. So if you have a regression for housing data, then you can take all that information and predict if you have a new house that's being sold, predict the price that that house is going to be sold. Cluster analysis, exact same thing. So if you have all your historical customer and their segments, and there's a new customer come in, you can plug that new customer into the algorithm and it'll tell you what segment it's in, whether it's first class, business class or economy class. Finally, prescriptive analytics. Excuse me. So it's a scientific way to find out the best course of action given the analysis from descriptive and predictive. And usually this one is the one that people have the most questions on because it is kind of confusing. What do you mean by best course of action? So a popular example, optimization using Excel or pricing analytics. So I'll give a quick example. So let's say we have working with a charity, donating some you're looking for donors and they're donating X amount of dollar value. Well, you can use descriptive and predictive to try to understand, out of 1,000 people, how many people is going to donate, and out of the 1,000 people, who are the different kinds of people in there? So are there people who's high income, who donates lump sum at the beginning of the year? Are there people who only donates at Christmas time, but they'll do $10 each time and things like that? So that's descriptive and predictive. Well, with optimization and prescriptive models, you're looking at things more like, okay, out of this 1,000 people, we have budget to advertise to them 5 times a year. Well, who should receive what advertisement, and how do we use our historical information to act on these advertisements so we get the highest amount of revenue? So there's like mathematics involved in that. Another, I think, more common example, let's say you have a big factory with thousands of people and materials. You can run an optimization model to schedule everybody and then figure out the optimal inputs and outputs to run your machine the most optimally. And an easier analogy, I think, and not an exact analogy, but budgeting. So, with historical data and future data, budgeting allows you to affect your future outcome. So that's kind of prescriptive analytics. And I talk about all of those. And just a final slide here for this section. Analytics data science, not just a discipline or a department. It's a state of mind. It's a new way of doing business. And one of my professor, he always says this: in God we trust. Everyone else bring data to the table. So that's the end of the types of analytics. And we'll jump right into the applications of analytics. But I see Fiona has a question. So are segmentation model represented by a formula similar to a regression formula? That is correct. So there's different ways to do segmentation. The example I used was called cluster analysis, and that's a algorithm. The high level structure is similar to a regression formula, but it's a different type of model. Any other questions? Well, take a sip of water. No problem, Fiona. Alrighty, on to the final section. High impact, low cost initiatives in analytics and application of analytics in business in general. Here we go. There we go. Okay. So there's 3 main things I want to talk about in this section. So data analytics and business strategies, number 1. Number 2 is analytics education. And number 3 is BI. There we go. Forgot for a second. So analytics usage. So I just want to make a quick distinction right off the front. There's people sometimes get kind of confused when I talk about analytics, because especially if you work in a tech company versus a traditional business company, the use of analytics is actually pretty different. So the distinction here, analytics supporting core business. So analytics can be used to support all the functions within an organization, be it management, marketing, finance, or HR. And I would say pretty much any traditional business or organizations, government, charities, whatever, could benefit from analytics. And then there's a second type on the right there, analytics that's core to the business. So analytics is actually part of the service offering. So you could be a dashboard for a client, recommendation engine for products, embedded analytics, and things like that. Generally, on the right there, I'm talking the easiest type of group of business that fits in there are tech businesses. So if you're a tech business, you have a team of computer scientists, and your core business model is the data, and you use the data to do whatever it is that you do. So that's a little bit different. So for the most part today, I'm going to talk about the left, which is analytics supporting core businesses and more traditional businesses. So where do you find value when you don't have a specific use case? Super high level. And I talked about this earlier, right? So information, right? A lot of times in a less data-driven and information-driven organization, communication and information gets lost. So your employees might say, I don't know what happened, or I think this happened. Going to, okay, I know from our data, 78% of the time, X happens. And then with an analytics function, you can say, I know if I do XYZ, 80% of the time, the outcome will be this. And it will be the desired outcome that we want. So it's almost having like a crystal ball, so you know exactly what you should be doing with your important processes, whether it's manufacturing, services, retail, doesn't matter. Knowing and being able to measure and improve and modify is key to having a successful whatever activity it is you're doing. And data, I think, especially today, super underutilized data, utilized assets. Sorry. So you don't buy a refrigerator and only put 2 apples in it, right? You don't have a bunch of empty space. Same thing with data, right? You don't have tons of data or the ability to store data and use data, but not use it. It's literally wasted value that's sitting around that you're not using. So analytics and data science and all this stuff we're talking about today, it's methods of utilizing those assets that already exist. And a common thing, especially for bigger company, is we have all this data that's siloed or not being used, and how can we be using them? So this whole section is talking about what is the strategy and how do you figure out that strategy to use these data? And so it's organized, right? So I think an analogy there, right? You can't really have a library with just piles of books on the ground. You have to have a system that's organized so that people can use it. And then reactive versus proactive problem solving. So going from, everything is on fire and we gotta fix all these problems to everything is running smoothly and we want to deal with problems that might come up before they even happen and prepare for it. That is kind of the key and where we want to get to. And ultimately, I think it's like automated almost everything. That's like my dream, at least. Wake up, coffee's already made, don't have to do my taxes, go to the shop and walk out and everything's already paid for and go straight into my tax tax files and things like that. So that's the dream. What does analytics mean for management? Providing information on blind spots for decision making, deal with potential problems proactively, find key levers to drive bottom line, cut down time through automation. And I think this last part is really important. It's really driving curiosity and help you ask deeper questions, right? So a lot of times, even in normal reports, in the top line numbers, you're only looking at very siloed information. So let's say you're looking at, I don't know, outputs of apples at a grocery store. And this might be a poor example, but you can track number of apples across time, and you're looking at seasonality, and that's already decently sophisticated. But then, what is the factors that's driving apple sales, and going really deep, and what do people buy apples? What are other things that they are buying, and what time are they buying at? So getting really deep and really granular and asking interesting questions. I think that's, at least for me, that's like the most important and super interesting part, and why I love my job. I'll just go back, see if any questions. Cool. Okay. So objectives of your data and decision-making strategy. So most organizations don't have this. A data or a reporting or information flow strategy. Even and I'm not talking about IT. I think IT strategy. This is more information and decision-making strategy. So first off, like, what are the main objectives of your firm, and how do you track the progress of these objectives, and not only the progress, but also not only the outcome, but also every step leading up to the outcome in every single department. How are you tracking that? How often are you reviewing the numbers? How are reporting set up? Is it weekly, monthly? And are you analyzing those data in a recurring and structured manner? And what's your process to update and improve on these important activities and processes? So, all of you guys have work in a process of some sort, right? And you're probably visible to, you probably see only a part of the process. Ideally, you will be able to measure the entire process. Everybody can see it and know how everything is doing, and how do we improve different areas. That's really kind of what analytics and data is supposed to help you do. So this is just a really high level kind of questions to ask. When other companies and organizations build out their strategies, it's a lot more sophisticated than this. And then looking at strategy for analytics, right? Keeping in mind, analytics is not just like you can hire a guy and that's it. It's a problem-solving method for everybody, and it requires a bunch of other things. So this is the 5-star strategic analytics model. I think I stole this graph from like a strategic textbook. Sorry, I didn't even steal, but I'm just using it for the slide. So analytics excellence. Well, you have to have the right people, structure, making sure objectives are aligned, the processes are in line, and systems in line, right? Just a quick note. So on the left, visualization helps non-technical people understand complex information. So a lot of times I think people operate, especially in businesses organization that's been around for a while. A lot of the processes are just kind of there, and you don't think about continuous improvement. And I see this in a lot of our clients. While data will help you drive kind of those improvements, and in order to make change, people like me have to do a lot of convincing and education with data. And the only way for me to do that is really through visualization. A lot of times people have to be able to see the data visualizing in order for them to really connect with what you're trying to do. Data value directly correlate with how well you can communicate the data and implement change. Super quickly, data for each function, right? So there's accounting and finance. Obviously, accounting is pretty much the only source of data that every single organization has, because it's the only sort of source of data that you're legally supposed to track, because you have to pay taxes. So we have, transactions and financial analytics, and there's a ton of topics in there: forecasting, zero-based budgeting, risk analysis, and things like that. Marketing, you're generally looking at your customer and your advertising efforts, but there's a bunch of other things. Analyzing transactions, understanding campaign performance, sentiment analysis on customer reviews. So, let's say you're a restaurant with 200 restaurants, a chain with 200 restaurants, sorry, and you want to analyze all the reviews that's in those individual restaurants. Usually you're looking at, okay, the average review for restaurant A is 4.2 stars and the other one is 2.1 stars. Then you're like, okay, one is better than the other. But you can use analytics to dig deeper, right? How does the rating change across month? Can you analyze the data using machine learning to classify the bad reviews? So for all the reviews that's less than 2, what are the categories? Is it because of service time? Is it because the food doesn't come out hot enough, or the food is just bad, or maybe the waiters are really rude? So things like that. You can analyze large amount of data with analytics using what I just talked about was text mining / natural language processing. Sales, so people have CRMs, so you're looking at customers as well as transactions in those. HR, so HRIS, HR information systems. There's a couple of different acronyms for those, but main topics, you're looking at attendance, productivity, absenteeism is a big one, recruiting is a big one, performance, compensation, all those type of things. You can do pretty sophisticated analytics on those. And other ones, pretty much every organization and business have their own type of data and systems that they use. So even for zoos, there's ZIMS, Zoo Information Management Systems, that tracks, how often the animals are eating and which animals are boyfriend, girlfriends, and things like that. It's pretty hilarious stuff. You can look it up. Or maybe I find it hilarious. People probably don't. And then, housing organizations have their own ERPs. Manufacturers have their own ERPs and things like that. Data education. So super quickly, this is an interesting slide I took from Deloitte. So technology grows exponentially. So I'm not sure if people heard of this thing called Moore's Law, but essentially the cost of technology halves every, I think it was 16 months, but essentially every 2 years, technology doubles in performance. So it could be your computer memory's size is twice as big, or runs twice as fast. But it also applies for images like pixels. So TV's resolution doubles every 2 years, or camera resolution doubles every 2 years. So that applies. So you can hear technology grows at an exponential rate. People also learn at exponential rate, but a little bit slower. So there's business, but a little bit slower. So there's public policy, but a little bit slower. But you can see here the gap in the 1990s. If you take a vertical line through the 1990s, that gap isn't as big. But then if you go to the 2000s, that gap is growing. And then 2010s, that gap is growing. And the gap is only growing bigger and bigger and faster and faster. And that's really the scary part of, I think, the world we live in today with technology. if you don't use data and analytics and data science and keep up with your competition, uh, there's uh, there's only going to be the gaps are only going to grow bigger. I would say education in terms of investment is probably the best use for an organization. So for a relatively non-technical analyst, assuming you know how to use Wi-Fi and Excel, you can learn BI tools like Tableau, Power BI, Click. I think within 2 to 4 hours, the basics. Or you can learn how to code and do statistical analysis in 8 hours. And I know this because we teach both of these for non-technical people. I think the hardest time I've ever had was there was a group of middle-aged HR managers, and they had a hard time, downloading data and using Wi-Fi. But that was a whole other thing. If you know how to use Excel, well, first off, you should really know how to use Excel. But we have a course next week next week's intermediate Excel, where maybe I'll run a beginner Excel if there's enough demand for it too. But ultimately, right, never stop learning. Technology and new methods are growing super fast, even for me. And I'm reading academic articles like every day. It's there's always new ways of doing all these things constantly. And understanding the fundamental and how structures of everything work will speed up your learning exponentially. All right, the final one. So KPI reporting and dashboard. I want you to take a sec and think about how much time and resources does your department or company spend manipulating data or creating reports, right? And different people I talk to, it could go from 2 hours to like 2 days a week. And this is just kind of the process people go through, right? So, you let's say you're analyzing your HR data for recruiting. Okay, so you go to your system, you pull out some data, you do some copy and pasting, get the tables you wanted. You run some functions, maybe you do some ratios, look at attendance, whatever. And then you do a pivot table to aggregate some information, some more copy and pasting, frustration. You build a summary table, you do some graphs. And then finally, you're taking that and actually analyzing the data and making a decision. So that entire process can be automated if you're doing it more than once using tools like Excel, Power BI, and BI tools. So if you remember that spectrum earlier on, going from no data to AI, BI is really the next big investment that companies are doing. I think in the past 5 years, and I think probably for the next 5 years, most of the organization will shift into using BI tools and having BI functions. And then there's a decent amount of companies already starting doing descriptive and predictive analytics. And usually they do this by hiring like 1 or 2 data scientists. And there's merits to that, but that's for another time. But just to say, if you're spending a lot of time on reporting and your information's and reporting structure isn't as organized, then it's worthwhile to build a strategy as well as implement some sort of technology to help with that. So just a quick check on questions. We only have 2 slides left. So I just want to share. So I try to distill down some learnings from I think a 50 plus project we worked on since we started the firm. So some signs of analytics versus non-analytics firms, and you can see pretty quickly when you start just talking to people. So in non-analytical, you have no data analytics strategy. You have pretty poor tracking on major activities. You have unstructured reporting. You have spreadsheets in multiple locations and stakeholders. Maybe Mary in one department is tracking the exact same thing as Bob in a couple of desks away, things like that. and no process for continuous improvement. So that's an interesting one. It's like continuous improvement. It's like having a process for a process. Having a process for improvement. So, you have processes, but then you also need to have a process to improve that process. That makes sense. Analytical organizations, right? Defined analytic strategies, have a innovation and experimental mindset. They track things very religiously. Everything, reporting and analysis all supports the main strategy, and it's very structured and has a team for it. It's got systems, databases, or even just organized Excel libraries, right? And then a defined process for continuous improvement. And then running successful versus unsuccessful analytics project. Unsuccessful ones, usually building tools that's more one-off and not ROI driven, very focused on a very small piece of the process. Unsuccessful analytics project, once it's implemented, has low adoption because of misalignment of process, people, and strategies. And then general, I think, skepticism from culturally within an organization on the usefulness of data and analytics. And then successful projects, right? Usually those companies want to be best in class. They're open to explore outside of their traditional way of doing things or how the industry does it because they want to be better than the industry. They want to lead the industry. They integrate tools for a whole system and not just little pieces of patchwork here and there. They have cross-discipline teams. I think that part isn't always true, but a lot of times I see that as a pattern. Use analytics to change the economics and not the technology. So that's an interesting one, right? Analytics, a lot of people think it's like, oh, that's an IT thing. It's not. It's a business or it's a decision-making thing, and you use it to improve things, to make your margins better, to increase your revenues, to decrease your cost. It's not just a piece of technology you can buy and it's there. So that's it. To end off, please give us some feedback. Email me. You should have my email from all the event pages. Find us on Google and Facebook. Follow us. Give us a 5-star if you enjoyed it. Check our website. Really, for us, want to make sure analytics, it's affordable for everybody and it's used by everybody. And if you have any interesting project, we're open to take on new projects for 2021. If I'm not going to see you again in the other workshops, I wish you very good luck in your data and analytics journey. Thanks, everyone.